Hello, and welcome to a special episode of Backer Breaks It Down. I just want to go over a few more examples of special right triangles that weren't featured in our previous two episodes. Okay, um, so just to remind you, in a 45, 45, 90 triangle, you have the two legs and the hypotenuse. If you know the leg, you can multiply by the square root of 2 to get the hypotenuse. And if you know the hypotenuse, you can divide by the square root of 2 to find the leg. In a 30, 60, 90 triangle, all three sides are different. You've got a shorter leg, a longer leg, and of course the hypotenuse. The shorter leg, if you know it, you simply multiply by 2 to get the hypotenuse, and you multiply by the square root of 3 to get the longer leg. If you don't know the shorter leg, I would definitely find it first because it is a really useful measurement to know. Okay. In problem number 7, notice that we have a 45, 45, 90 triangle and a 30, 60, 90 triangle, and we want to find the values of A and B. Okay. So this it's probably going to require us to do a couple of steps in order to do so, because if you notice, A and B are sides of the 30, 60, 90 triangle, and I don't know anything about that 30, 60, 90 triangle. I do notice that this right here is a side of my 45, 45, 90 and also of my 30, 60, 90. So the length of that side is key to finding A and B. Okay. I know the hypotenuse in my 45, 45, 90 triangle. So what I can do is I can divide that by the square root of 2 to get the leg. Okay. So if I take 6 and I divide by the square root of 2, I do need to rationalize this denominator because I'm not allowed to leave square roots on the bottom. So I need to multiply the top and the bottom by the square root of 2. Okay. On top, because I'm multiplying an insider and an outsider and they don't mix, I simply have 6 root 2. On the bottom, square root of 2 times the square root of 2 is the square root of 4, which is simply 2. And then I should reduce that outside fraction because I can. All right. 6 divided by 2 is 3. So I get 3 root 2 as the leg in my 45, 45, 90 triangle. And so that's that blue squiggly line is 3 root 2. Now in the 30, 60, 90 triangle, that is opposite the side. It's opposite the 30-degree angle. So what that means is that is the short leg in my 30, 60, 90, which is the best one to know because it's just a matter of multiplying to find the other two. So A is the long leg in my 30, 60, 90. So I know the shorter leg. So if I multiply it by the square root of 3, I'll get my longer leg. So side A is 3 root 2 times the square root of 3. I have a 3 on the outside and the inside. 2 times 3 is 6. So 3 root 6 is the length of side A. To find the length of side B, well, once again, I know the shorter leg. So I can multiply by 2 to get the hypotenuse. So I have to go the shorter leg, 3 root 2 times 2. This gets me 6 root 2, and that's the hypotenuse of my 30, 60, 90. Okay. In this problem here, we are given that ABCD is a trapezoid, and they want us to find X, Y, and Z first, and if necessary, of course, express those in simplest radical form. Notice that X and Y are both sides of my 30, 60, 90 triangle there. And in that 30, 60, 90 triangle, I know the hypotenuse is 8. X is opposite the 30-degree angle, making it the short leg of my 30, 60, 90 triangle. So I know the hypotenuse. I can divide by 2 to get the shorter leg. Okay, so if I do that, 8 divided by 2 is 4. Okay. Now that I know the shorter leg, I can simply multiply by the square root of 3 to get the longer leg. So 4 times the square root of 3 is the length of y. Okay. And z, I don't have to do any math to find z. Notice that z is opposite that segment there. So DC is going to be equal to 6. So z is 6. Okay, so nothing like weird going on there. Okay, so we got that x is 4, that y is 4 root 3, and that z is 6. They want us to find the perimeter of ABCD, so that means we need to know the length of all the sides. Okay, so like, let me get out another highlighter. Like I know this side is 8, DC is 6, the segment y is 4 root 3, this is 6. So what I need to know is BC and then the leg of the 45, 45, 90. And the leg is pretty easy because, like, remember, this right here is 4, and it's going to be congruent to this piece, so that would be 4, which means that this right here is 4. So in my 45, 45, 90, I know the leg is 4. I want to know the hypotenuse, and that's easy. I just multiply by the square root of 2. So BC would be 4 root 2. Okay, so now I've got the lengths of all segments of all the sides. And so now I just need to add them together. Now clearly I'm going to get a decimal here because like I'm adding radicals, because I have to go like, for my perimeter, I have to go 8 plus 6 plus 4 root 2 plus 4 plus 6 plus 4 root 3. Okay. And so I'll just throw this into a calculator. That's the easiest thing to do. And I end up getting like 36.6 for my perimeter. Now, when it comes to the area of this trapezoid, area of a trapezoid is 1/2 the height times base 1 plus base 2. So we already like have some of this stuff. Like clearly the height is 4. Base 1 is 6. And then these 3 pieces added together is base 2. Okay. So if you think about it, like going back to what I just did for perimeter, like take that out and take this out, add up those remaining pieces. That's going to be like base 1 plus base 2. Okay. So what is that? 16 plus 4 root 3. Yeah. So yeah, because you would have 6 plus 4 plus 6 is 10, plus 6 is 16, plus 4 root 3 is base 1 plus base 2. So I'll just get a decimal for that. The height is 4, and then I'm going to multiply that by 1/2. So throw that into a calculator and you get like 150.6 square units. Okay. So that was interesting, adding with square roots, huh? But really, you know, we used our 45, 45, 90, and 30, 60, 90 to find those missing sides, and then perimeter and area is just some calculating. Okay. And so that's how we can further apply these two triangles in some geometry problems. Okay. And that's how Backer breaks it down.